Hello students. In the last lecture we had covered about the theory of what the concepts of energy and how it is involved in the SHM. All those things we have seen in the last lecture. Now in today's lecture I am going to discuss some basic problems on this concept that we have learned in the last one. Okay, and if I might feel that I should take more some advanced problems, so I'll take one more lecture in the after this lecture, guys. Okay, so let's have some basic problems on the idea of energy, and then we will see that do we need more questions to do or not. Okay, so let's start with the first problem that I'm having for you is problem number one, guys. So problem number one. Okay, so the question says like this, that a particle doing SHM has has time period of 2 second 2 second. Okay, now it says further, guys, that find the find the time at which it will have it will have it will have 75% of the total energy in the form of in the form of kinetic energy. It is it is starting from mean position. Starting from, guys, what? Mean position. So this is the question given. It's a very simple problem, guys. Okay, we are just going to learn and see that how do we use the concept that we have learned in the last lecture. Okay, so if you want, you can pause the video here and you can try by yourself. Otherwise I'm going to solve. You can see the solution, guys. Okay, so solution. So, guys, what is said here in the question? A particle is doing SHM, has a time period of what? 2 seconds. So t is given how much, guys? 2 seconds. And find the time at which it will have the 75% of the total energy in the form of kinetic energy. So let's say, guys, suppose this is our uh, particle right now here, and this is our plus a and this is our minus a, and let's assume that the particle is moving in the positive direction. Okay, let's assume, not a problem. So what it is saying that it is having the 75% as a form of what? The kinetic energy. Okay, so what is the time at which it is going to happen? So let's say at x distance, guys, this is going to happen. Okay, let's say here it is going to happen that uh, the kinetic energy will be what, guys? 0.75 of total energy. That is going to happen. Okay, so we know that at the mean position you have the maximum kinetic energy. Okay, at the mean position you have what? Maximum kinetic energy, and as you go, guys, here you will have what? Minimum kinetic energy. So the graph goes like this, you know that. Okay, the parabolic downfall you can see of the kinetic energy. So here I can say, guys, that the total energy is how much? It is half k a square. Okay, this is the total energy. So we want the kinetic energy should be what? 0.75 of this. So let's write this side. Okay, and we also know that kinetic energy can also be written as what? Half k a square minus x square if x is the position from the mean. Okay, so if I use this idea, I think we can omit this, guys, and we have this will be 3/4 of a square, and this will be a square minus x square. So from here, guys, what we got? X square is equal to a square by 4 or x is equal to plus minus a by 2. Okay, so it means that the positions where the particle could be, where we have what, the kinetic energy is equal to what, 75% of the total energy is what, plus minus a by 2. So now if suppose guys, if the particle is moving from the mean position towards what, this side, we can calculate the time guys. The time would be how much? If you see, we know that x is equal to what, x is equal to a sine omega t plus 0, because it is starting from the mean position. So x we want guys what, plus a by 2, let's say. So it will be what guys, it will be a sine omega t. So a cancel. So from here guys, what we got, omega t is equal to what, pi by 6. So t should be equal to what, it will be pi by 6 omega, and omega guys we can write as 2 pi by t. Okay, 2 pi by t. So the t will go this side guys, pi cancel. So t will be 2 by 12, because t is given what, 2 seconds. So it is going to come guys what, 1 by 6 second. So if let's say it is going from mean position to this side, then also it is going to take 1 by 6 second. And let's say if it is going this side guys, then also it is going to take what, 1 by 6 second only. That is for sure. Okay, so I have solved in a one way. Okay, now guys, I hope you understood the idea of this question. Now let's take one more question. The question is guys, let me write the question again for you. The question says like this, problem number 2. Okay, problem number 2. So the question says like this guys, that a particle of mass, a particle of mass 0.1 kg is executing SHM with amplitude of 10 centimeter. When the particle passes through mean position passes through mean position its kinetic energy is 8.3 into 10 to power 3 joule, 10 to power minus 3 joule. Okay, 10 to power minus 3 joule. Obtain the equation of motion of the particle if its initial phase constant is pi by 4. So guys, this is the second question for you. Okay, so if you want, you can pause the video and you can try by yourself. It's again a simple problem only. Okay, but if you want to see my solution, I am going to solve it. You can check the solution. Okay, so guys, let me solve this question for you. So question says solution guys. Okay, so guys, the question says that a particle of mass 0.1 kg is executing SHM with the amplitude of what, 10 centimeter. Okay, so let me make the figure first for you. So guys, let's say this is what, plus 10 centimeter, and this is what, minus 10 centimeter, and the mass is given how much, 0.1 kg. When the particle passes through the mean position, its kinetic energy is guys, here when the particle is, okay, its kinetic energy is given how much, 8.3 into 10 to power minus 3 joule. obtain the equation of motion of the particle if its initial phase constant is what, pi by 4. So guys, if you see, the thing is, if a particle is moving like this way, okay, and it is having the kinetic energy is this much, we know that from here guys it is the total energy also, okay, but let me see how we can solve this problem guys. So if we see, if I write half m v square is equal to what, 8.3 into 10 to power minus 3, or if I write half m omega square a square is equal to what guys, your total energy, both can be written, okay. So if, let me write like this way only, and let's see that can we do something. So half m is guys 0.1 omega, let it be like this way only. A is given guys what, 10 centimeters, so 10 into 10 to power minus 2, that is what, 0.1. So 0.1 into 0.1, and that is equal to what, 8.3 into 10 to power minus 3. So if you see guys, 1 2 3, this is gone. So what we have, we have omega square is equal to what guys, I think everything look fine only. So guys, this will be what, this will be 170, sorry, 17.6, that is what your omega square. Now if you see, fine guys, fine. Okay, so we got omega. So omega guys, we can get from here, omega is what, it is under root of what, 17.6, okay, it is what, 17.6. I think I have taken this 8.3, but it is given in the question only 8, so that's why guys I thought maybe why we are getting some complicated result, okay. So guys, take it what, 8.0 only, okay, take it 8.0 only, okay. Let me change the color. This is, we are making 8.0. So guys, if I take 8.0 here, I think this we can take as 8.0 only. So this will be also what, 8.0. So guys, this whole thing we can write as omega square can be written as 16. So omega is equal to what, 4 radian per second, okay. So omega we got guys, so we can write the x. So x is equal to what guys, a sine omega t plus 5. So x is equal to 10 centimeter sine 4t plus pi by 4, because initial phase constant is given guys what, pi by 4. So this would be the answer, okay. So guys, this is also an easy problem, okay. I am taking only easy problems in this lecture, okay. Maybe I feel that we should take some more good questions on the energy analysis, so I'll be taking one more lecture on this guys, okay. So let me take one more problem. So problem number 3 guys, problem number 3. So what this problem number 3 says guys, it says like this, that potential energy of unit mass moving in one dimensional conservative force field is given by u is equal to x square minus 4x plus 3. Find equation, sorry, find, question number 1 guys, equilibrium position of the body, equilibrium position of the body. Second question is, guys, that show that show that the oscillation oscillation of a body about equilibrium about equilibrium about equilibrium is simple harmonic is simple harmonic. And third, find its time period find its time period. And fourth, find the amplitude of oscillations find the amplitude of the oscillations if speed at equilibrium if speed at equilibrium is 2 root 6 meter per second. If speed at equilibrium is 2 root 6 meter per second. Okay, so this is the question, guys. Okay, there are multiple parts of this question. If you want, you can pause the video and you can try by yourself. Okay, I'm going to solve this question for you. So guys, let's see the solution of this particular problem. So solution. So guys, here it says potential energy of a unit mass moving in the one dimensional conservative force field is given by what? This. Okay, so we have learned this thing in the our work power energy chapter, that F for a conservative force field is can be given as minus du by dr. Okay, and because if you see it is a one dimensional field, we can directly take this as a what? Minus du by dx also. Okay, so there is no partial differentiation we have to perform. Okay, so guys, if we do that, we can get the force F is equal to what? X square minus 4x plus 3. So this will be what, guys? It will be 2x minus 4. So if we write, guys, a is equal to what? F by m, and mass is what? It is a unit mass, so we can directly write, guys, that this is equal to what? 2x minus 4. So if I, guys, take 2 common, it will become what? X minus 2, which is looks equivalent to what, guys? If you see, I think, sorry, here I have missed the minus sign, guys, so this will be minus. Is this okay? Yes. So guys, this will become, if I take minus common, so it will become minus 2x. Okay, minus 2x minus 4. Okay, sorry, so guys, minus 2x minus 2. Okay, so we can compare this with this formula, so we can get that x naught is equal to what? 2. It means our equilibrium position is 2, guys. Okay, and this is your part of the answer. And after that, guys, second, they had asked that show that the oscillation of the body is about the equilibrium position is what? Simple harmonic. This is also we have proved, this is also we have got it, guys. Third one is what? Find its time period. So second is done. Okay, second is also done. Coming to C, guys, that is what? Find its time period. So time period is equal to what? 2 pi by omega. So 2 pi divided by omega is how much, guys? That is root 2. So we will get that is what? Root 2 pi second. So guys, that would be the answer, okay, of this question. And coming to the last one, guys, find the amplitude of the oscillation if the speed of the equilibrium is what? 2 root 6. So guys, we know that the speed at the equilibrium is what? Maximum, and that is what? V max, and that is what? Omega into A, and that is given to you 2 root 6. Omega, guys, we know that is how much? Root 2 pi. A is equal to 2 root 6. Is this okay, guys? That is fine. Okay, and I think everything is fine guys, it looks fine to me. Oh, something I have done mistake, yes. Omega is root 2 only na, so guys this we have to delete. Okay, so root 2 into a is equal to what, 2 root 6 guys. So a is equal to, a is going to be how much, a is going to be uh, root 12, that is how much guys, 2 root 3. Okay, so it will be in meters, of course it will be in meters. Okay guys, so that's it. Okay, this is also a simple problem only, and we have found out all the parts of the solution. Okay, now let's see guys one more problem. I can take one more problem for you, and then I think for today we can close the session. Maybe tomorrow I'll take one more lecture. Okay, so let's see guys the next problem. So problem number 4, problem number 4, that is what is a particle of mass m, a particle of mass m is present, is present in a, in a potential energy field, potential energy field which is what guys, ux is equal to u naught 1 minus cos ax. U naught in bracket guys what, 1 minus cos ax, where u naught and a are positive constants, constants. Find the time period, find the time period of the oscillations, of the oscillations of the particle, of the particle if the oscillations are, if the oscillations are, oscillations are very very small, very very small. So this is the question guys. Okay, so if you want you can try this problem, I am going to solve. Okay, so guys let's see the solution of this question also. So guys this is also an easy question. So if you see the field is what, one dimensional conservative field, so we can directly find the force. So force will be what, minus du by dx. So it will be what guys, it will be minus of u naught, and this will be 0, and this will be plus a sine ax. So guys directly we can write f is equal to minus u naught a sine ax. So guys acceleration will be what, f by m, that is what, minus u naught a divided by m into sine ax. But guys if you see it doesn't look like what, an SHM equation. Okay, so if a general oscillation is happening then it can't be considered as a what guys, a simple harmonic motion. But because here in the question it has been said that if you take the oscillations are what, very very small. So guys if we take the oscillations are very very small, it means the theta would be what, very very small. So ax will be what guys, it will be very very small, very very small. So in that case guys we can do this approximation, we can do this approximation, that is sine ax can be considered as equal to what guys, ax. Okay, so if I do this guys, I can say acceleration is equal to what, minus u naught a, as this is let's say a dash, acceleration is what I am representing with the a dash. Okay, so minus u naught by a divided by m into what, ax. So it will become what guys, minus u naught a square m into what, x. So acceleration is given by what guys, this. So this we can see that this is guys is this can be compared with what this relationship. So we can say that omega is nothing but what, under root of u naught a square divided by m. So guys, it can be considered as what, u naught a square divided by m. So guys, if we got omega, we can get the time period. So time period is what, 2 pi by omega. So guys, it will become 2 pi under root of m divided by u naught a square. So guys, that would be the answer of what, the time period. Okay, so if you see guys, this is also a good question. Some sort of approximations we have to think, and then we can do this problem. So guys, okay, so we got some basic ideas of what, the energy analysis of an SHM. I'll take some very good problems guys in the next lecture, from where we will get some concepts also that we should keep in mind. And after that we can move towards the very interesting part of the simple harmonic motion chapter, is that is what, calculating the time period of different systems, okay, performing SHM. So see you guys in the next lecture. Okay.